Welcome to my series on grade 7 mathematics. And this time this is on quarter 2. And in this video, I'm going to discuss two uh, key topics: introduction to sets and the types of sets. So here are the objectives for this lesson. At the end of this video, you'll be able to define a mathematical set. You'll be able to describe sets and identify their elements. And lastly, you'll be able to differentiate different types of sets. Firstly, let us define what is a set, particularly a mathematical set. So, in mathematics, a set is a well-defined collection or group of objects. So there is an emphasis on the word well-defined. It has to be well-defined and not just any collection or not just any group of things or objects. Now the objects there can be different or can denote different things. It can be objects, it can be ideas, it can be persons, but in math we will be dealing mostly with numbers. So how do we know if it's a well-defined group or collection? Now it is considered as a well-defined group or collection if the elements of the given set are distinct and specific. So it means that each of the elements or the elements are different from each other, yet they are related in some properties or characteristics. So magkaiba sila, yung bawat elements, yet they relate to each other in terms of some characteristics or properties. So here are some examples of sets, and these are well-defined groups or collections. So the first here is the collection of children in grade 7 whose weight exceeds 35 kilograms. Now, this is well defined because there is this qualifier there that makes the elements of this set specific and distinct. No? Only those children or students who are weighing above 35, because it says there that their weight exceeds 35 kilograms. So if a child weighs, or if a student, a grade 7 student weighs 34 or even 34.9 or even 35, then that child or that student is not part of that set. So that makes it a well-defined group and is considered as a set. Next, on number 2 example, the collection of even numbers from 2 to 12. So inclusive of 2 and 12, kasama si 2 and si 12. So here, define talaga na even numbers that belong to this set or this collection are only the numbers or the even numbers 2, 4, 6, 8, 10, and 12. And 14 and above do not really belong here because it is what? Defined. It is clearly defined in this type of set. And the third example is the collection of months in the year with 31 days. So there is a qualifier there. Meron talaga dong phrase that qualifies kung ano lang yung mga months na pwede dito sa group na to. So only those months that have 31 days, like January, March, and so on. So not all the months of the year can be part of this set. Now let's proceed to those groups or collections which are not well defined or they are not really sets. They're not really mathematical sets. They can just be considered as groups or collections, but they are not well defined. Okay, the first one here is the collection of all intelligent children in grade 7. Now, this is very subjective kasi ano ba ang basis ng intelligence dyan? So, is it those students who got a GPA of 90 above? Are they considered the intelligent? Or what? Are we just relying on the IQ? IQ lang ang basihan o ano pa? So, yan. Very subjective. Mahirap siyang i-define kasi nilagay na intelligent. Next is the collection of big books in the library. So, mahirap din yung mga adjective or yung qualifiers na big because we don't know exactly ano yung dimension, gaano kalaki yung big na sinasabi, anong length, ano width and thickness para ma-consider na big yung book na yon, no? And next example, the collection of vibrant colors. So paiba-iba rin yan kung maaari yung vibrant colors for me might not be vibrant color for other people. So these are some of the examples of collections which are not considered as sets. Now, here are some of the things that you need to remember, particularly in writing sets. A set is represented by a capital letter. Now, we denote sets using the uppercase or the capital letters of the English alphabet. So we say set A, set B, or set Z. And or sets use curly braces. No, yung brace, o sinasabi. And here are the examples. Set A equals open brace or left brace, 1, comma. So here, take note, there is comma, 2, comma, 3, comma, 4, comma, 5, and then you close it with the close brace or the right brace. So that's how we write a set. No? And next one, we have another example. Set B equals open brace or the left brace, blue, blue comma, space red comma, and yellow close brace. Now, in listing the elements of the set, each distinct element is listed once. So, isang beses lang siyang isulat. And the order does not matter. No? So, regardless if, say, the numbers are not really arranged in ascending order, it doesn't matter when writing sets. But of course, uh, for us to clearly write sets, we usually arrange the elements, no? If it's a number, we arrange it from least to greatest, no? And so with letters, yeah, ascending. Okay, so remember that in listing is that when you list, say an element repeats, you don't write it more than once. So you only write it once. Okay. The individual objects in a set are called elements. So ang tawag dyan ay elements at meron siyang symbol yung parang letter E. And always remember that the elements in a set can be, as I said earlier, it can be a name of a person, it can be things, animals, places, and numbers, of course, no, in math. Now let's go to cardinality. So what do you mean by cardinality of a set? Now it is denoted by the lowercase n or letter n, small letter n. Now it simply refers to the total number of elements in a given set. Now you have to count the number of elements in that set, and the number of elements is the cardinality of that set. So if the teacher asks, what is the cardinality of this set A? Then you just simply count the number of elements there. If it's not listed, then you have to check, no, depending on how the element is being described. So, for example, in set A, so you have elements 1, 2, 3, 4, 5. So the cardinality here is just 5. No, because if we count the number of elements, we have 5 elements in set A. And on set B, the one that we had earlier, we have the elements blue, red, and yellow. Hence, the cardinality is 3 because we have three elements on set B. So I hope you got it. Cardinality is simply the number of elements in the given set. Next, let's proceed to the types of sets. Now, the first type is the empty set. And as you can see on your screen, it's denoted by the symbol here of, and it can be denoted in two different ways, no? So you can have an open and closed brace without an element inside, so that can be considered as the empty set, or also known as the null set. And in other references, it's also called void set. So all these things are the same, no? Empty set, null set, void set. Pare-parehas lang. It can also be denoted by the notation, no? Na parang zero and you have a slash there. So here are some examples of empty sets. Okay, first is set A is the set of months with 32 days. Now we know that there is no month in in a calendar year that has 32 days. So therefore this is an empty set. And yeah, this is the example. So it is denoted by an open and closed brace without an element inside, or like a zero with a slash, no? Okay, next let's move to another type of set. Let's go to finite set. So from the word finite, this is a set that has definite number of elements, meaning you can figure out or you can count the number of elements in this particular set. Now, the empty set that we had in the previous slide is also an example of a finite set because we know that the empty set has no elements, zero number of elements. No, so it's definite. So it's a finite set. Another examples of finite sets we have here uh, set B is equal to 2, 4, 6, and so on until until 10. 2, 4, 6 dot 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 until 10. So we know that this is a finite set because we can count the number of elements. 2, 4, 6, 8, 10. And next we have uh, another set. Set C is equal to 1, 2, 3 until 20. So we can count the number of elements in this particular set, and since it's from 1 to 20, entonces the number of elements would be 20, or the cardinality is 20. So it's a finite set if the cardinality is a whole number, if you can really count the number of elements in that set. Another set we have set D is equal to 5, 10, 15 until 65. So here we can also count the number of elements in this set. On the other hand, we also have the infinite set. Now, as its name suggests, it's a set that has infinite number of elements, or infinite number of elements. So we have here, we cannot really figure out, we cannot really count the number of elements in that set. So we call it infinite set. Let's have some examples here. We have 3, 6, set E is equal to 3, 6, 9, 12, dot, dot, dot. Now the ellipsis there ellipsis, or yeah, the ellipsis means that it goes on infinitely. So, and we know that although this is this is a sequence of multiple of 3, 3, 6, 9, 12, 15, 18, and so on, but still we don't know what would be the largest multiple of 3. Hindi natin alam yun kung ano yung pinakamalaki. So, it is infinite. Uh, it is an infinite set. Next, set F is equal to 1, 2, 3, 4, and then dot, 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 or ellipsis, meaning it goes on. It's infinite also. And set G is equal to 5, 10, 15, 20, and so on. Dot, dot, dot. So these three sets are examples of infinite sets because uh, we cannot possibly count the number of elements, and the cardinality is infinite. Next, let's go to universal sets. So universal sets are sets wherein it contains all possible elements in a given context. No? So and this universal set vary, no? So hindi ito laging 1 to infinity, hindi ito laging parehas lang. It depends on the context in a given situation. So examples, uh, says universal set or capital U, as usually denoted, is equal to the set of whole numbers. So when you say set of whole numbers, it begins with 0, so like 0, 1, 2, 3, and so on. It's also infinite. So we don't know when it ends or where it ends. Another is, yeah, this is the listing, what, 0, 1, 2, 3, and so on. Next is another example of a universal set. Set U is equal to the set of all letters of the English alphabet. So in this case, it's a finite set because we can count that there are 26 elements here because we know that there are 26 letters of the English alphabet. So set U is finite, but still it is universal because in a particular context, ito yung nakalagay doon. Set of the English letters of or set of the letters of the English alphabet. So the elements of that set would be A, B, C, D until Z. So it depends on the context. Next, we have equal sets. So when we say equal sets, these sets, it can be two or more sets, these sets contain exactly the same elements. However, of course, kahit parehas silang elements, probably the arrangement of the sets or of the elements differ. So doon lang sa arrangement nagkakaiba. So we have here example. So say we have set A is equal to 1, 2, 3, and set B is equal to 3, 2, 1. Now, we know that set A and B contain the same elements. Pareho silang ang elements nila 1, 2, and 3. And the difference is the order on which these elements are written in each set. Sa set A, ascending, 1, 2, 3. Sa set B naman is descending. So, therefore, set A is equal to set B. So, remember, if it's equal, dapat parehas yung kanilang mga elements. They have exactly the same elements. So, hindi pwedeng ang parehas lang sila ng, like, three of their elements are the same. And they differ by one element. They are not considered as equal sets. So, dapat lahat ng kanilang elements ay parehas. Exactly the same. Now, on the other hand, the equivalent sets, these sets are sets that have the same number of elements. So, hindi sila parehas ng laman, hindi sila parehas ng contents, but they have the same number of elements. So again, Ang equal sets, same elements talaga. But here, same number of elements. So if one set has five, not five elements, the other set must have five for them to be considered as equivalent sets. So you have here example. So you have set A is equal to 1, 2, 3. Therefore, this set A has three elements. And the other one is set C has elements which are A, B, and C. And set C also has three elements. So they have different elements, but they have the same number of elements. Set A has three elements, set C has three elements. Therefore, set A and C are equivalent sets. I hope that is clear to you. Okay, now let's go to the ways of describing a set. Now I just only considered the two most common, but there's actually another one, or there are two more ways of describing a set. The other one that I did not include here is the description or uh, the verbal way of describing a set. Now, basically, you just describe it verbally or audibly, and the other one is through a Venn diagram. So here, the most common are these two ways of set notation or two ways of describing a set. The first one is the set builder notation, and the other one is the roster, or another way of saying the listing method or listing notation. So in set builder notation, the elements are just being described, and there's a way to describe the elements there. But on the roster or listing, or the roster method or roster notation, you have to list down the the identified elements of that set. Okay, let's go to the set builder notation. So here are some examples. Now, when writing or when describing sets using the set builder notation, you have to uh, follow this way. No? So you have to write first the name of the set. So in this case, you have set A, and then equals, and then you start with the left brace or the open brace, and then you begin with X. So X here stands for what? Uh, the universal set. So you're saying that this set, okay, uh, comes from a universal set. Then after that, the first X is the universal set, and then there's a slash or that bar there. It's not really a slash, but that vertical bar or the vertical bar, which represents the phrase such that. So we say X such that X. Okay, that should be X such that X, and then you define it. So in this case, for set A, X such that X is a counting number from 1 to 13, and then close brace or the right brace. So here we describe a set using a phrase, no? X such that X, and that is always the case. That's a format. You need to have that inside the brace. So after writing the left brace, you put X such that X or X bar X is blah blah blah. So that's where you describe now the set. In this case, is a counting number uh, from 1 to 13. Now let's go to the next example. Set B is equal to X slash X, which the or X such that X is a primary color. So here the elements here are also well defined, because you would know that only those primary colors can be the elements of this set B. So again, you start with left brace and then X slash X or X such that X. So the X slash X there stands for the phrase X such that X. Okay, and then the last example we have here, set C is equal to x such that x is an even number. So here, uh, it's described as an even number. So it begins with 2 and we don't know where it ends. So again, you start with a left brace, then x bar x, which means x such that x is an even number. So that's how you describe a set using the set builder notation. Next, you go to the roster or listing notation or listing method. So here you just simply list down the elements of the given set. So say for we have here some examples. Set A is equal to 1, 2, 3 dot 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 until 13. So this is actually the listing notation for set A in the previous slide, which is described as x such that x is a counting number from 1 to 13. So here we list down the elements of that set, which is 1, 2, 3 until 13. Then set B is equal to uh, red, blue, yellow. So this is the elements of that set. And set C is equal to 2, 4, 6, 8, 10, dot, 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 meaning it goes on and on. So a few things to remember when writing using or when representing a set using the roster or listing method. So, although I have already discussed this earlier, but let me reiterate this. So each element must be separated by a comma or a semicolon, but the most widely used is comma. Okay, each element must be present only once, so must be listed down only once. Don't need to write the elements more than once. A specific order is not required. However, it is convenient to list the terms in order. And ellipses or suspension points are used, no? Uh, they are used when there is a predictable sequence of elements. When you would know that these elements begins here and ends here. So that's why you use the ellipsis or the suspension points. So with this, I hope you learned something, particularly on the definition of a set, uh, writing sets in different ways or describing a set, and of course the types of sets that we just discussed. So with this, thank you for watching and stay tuned for my next video on uh, in in uh, in sets. No, so thank you. God bless us all.